All right, we're going to talk about making your own compositions. By the way, I'm going to close some of my compositions that I have. You can do that by usually, so what's going to happen is like on a browser, you'll notice that when you open up multiple documents, multiple images, that they begin to tab, like here. If you want, you can click on the little X and that would close them. Another way to do this is by going under File. Uh, I guess you don't have close. Sorry, I'm thinking of Photoshop. I guess you don't have a close option. All right. Now, in the previous examples here, everything I did was everything I did was I gave you the photo, right? Even if I opened up that photo I downloaded of the dog, right? Here's that. Oops. Let me find that picture of the dog. It's like I can open up this image and it has a certain dimensions. So 640 by 480 with a what's called a resolution. We'll talk about this, but the settings are already set. Okay. Usually when you take a photograph with your camera or with a nice Nikon or whatever it is, you are already setting things like the camera itself is setting some properties of your document. That being said, there might be times that you want to control the document. You want to control the dimensions. You want to control what's called the color space and some other properties. So this is where you might want to make your own document in Photopea. Okay, and we'll talk about how to do that. So I'm going to just go here and you can either go to File, New, or you can click where it says New Project. Either way would work. And I'm going to go here and you're going to get this window. And I'm going to be honest, we actually don't need this part. We actually really just need this part. Okay. I'll go through the different aspects here. The first aspect, this is the name of the file. So if you don't give it a name, it's going to give you some, very basic name like Untitled One or something super unimaginative. Okay. You might, if you're setting up a new document, you might want to give it a name. So Mr. Hurwich's awesome document. All right. Next is setting up your document's dimensions. Okay. Now, you could set it up in something like inches and or metric if you want to. For this course, I strongly recommend you use pixels. And why is that? Because eventually we are going to go to Adobe After Effects. And Adobe After Effects is eventually going to produce a video. Okay. That is what special effects are. They are video based. And because when you play back video, video is always going to be displayed on a device like a television or, like a phone, that kind of thing. And those kind of devices are always going to be measured via pixels. So, in my opinion, it's just easier to stay within pixels because you're already going to be working in pixels when you get to those programs. So this makes this just makes it easy to understand how everything relates. Okay. So there might be situations you do want to use metric or inches. That would probably be more in like a printing situation, but we're not printing in this particular course. You could use this program for that, but that's not what we're doing. So I'm going to keep it in pixels. And to be perfectly honest, anytime I set up measurements, in something like Photopea or Photoshop, I'm going to be using pixels for that reason. So let's just say for the sake of argument, I'm going to make my document 800 pixels by 600 pixels. Okay. So these essentially what we're doing here is these is going to be the dimensions of our composition. All right. Right now, the measurements can be whatever you want them to be. Eventually, when we start getting into video, there are sort of common measurements that are used in video, like standard definition size, high def, 4K, film, that kind of stuff. And we'll get to that eventually. Okay. The next is something called in Photopea, it's called DPI. It might be referred to as dots per inch. It may be referred to as pixels per inch. It may be referred to as resolution. Okay. So what is resolution? Well, The thing about resolution really means at the end of the day. So I mentioned that like on a computer, we measure things in pixels, right? If I opened up this photo of the dog and the dog had dimension, if I go back and let's get out of this for a second. If I go back and open up this picture of the dog is measured in certain pixel width and pixel height, right? And I sort of, once again, unfortunately, I can't really, it's easier when I'm doing this in person where I could literally show you on a screen it blowing up or not blowing up. Unfortunately, I can't really do that with the recording material, but like, you have to understand that like, I could make the picture of this dog bigger, right? And so unlike say a photograph that's been printed in real life from Kinko's or something like that, it's like these images don't have finite dimensions. They don't have like 2 inches by 3 inches or something like that because you can always just blow it up and it's bigger. Okay, kind of like the way if you project a film, depending on how close the projector is to the screen, it's like you can make it bigger or smaller. You know what I mean? That being said, even though pixels don't have a specific size, when we measure them for a device, we have something we can say how many pixels there are per inch. Okay. So in other words, I got this tape measure here. Okay. And if I were to take this tape measure and put it up to my screen, my computer screen that you're all viewing me through, and if I were to blow up my computer, like by blow up, I mean zoom in, I could see how many pixels there were, like I literally count them, in 1 single inch of my computer. Okay. And you could do the same thing on your phone. You could do the same thing on a television or, any kind of device. Okay. And that is what we refer to as resolution, sometimes referred to as pixels per inch, sometimes referred to as dots per inch. Why is it called dots? Because you'd be printing them and printers don't use pixels, they use dots. Sometimes, DPI, dots per inch. So they're all basically mean the same thing, which is how many pixels would there be in 1 inch? Okay. And this number can differ. I will tell you that when you take a photograph with your phone or a digital camera like a nice Nikon or Sony or whatever, your phone already sets this resolution. So for instance, in my phone here, if I were to take it, it would say how many pixels there would be per inch already in the camera. Okay, so you don't actually have to set it. The camera itself is already doing this. Okay. Um, where this comes into play is when we create a raster document, you have to say how many pixels there are per inch. And like I said, when it comes to cameras, there's no such thing as a wrong resolution. There just is what there is. But that being said, so you could have like, 100 pixels per inch, 200 pixels per inch, 300 pixels per inch, however many you want. That being said, there's something we call the minimum resolution. The minimum resolution means how many pixels per inch are necessary for good quality. Okay. Notice I say the word minimum because you can go over the minimum, but that doesn't necessarily change the quality. So this number of how many pixels you need to make a good image depends on how the image is going to be displayed. Is it going to be displayed on a screen like a computer or a, television, or is it going to be printed? Printing meaning like physically printing it out from like Kinko's or, like a printer or something along those lines. Um, the number is different. And in this class, for print screen, you need about 72 pixels per inch or a DPI of 72. Can you have a higher number than that? And the answer is yes, you can. That being said, if you were to increase the resolution, you're not going to see a quality difference. And the reason for that is things like computers and television screens and all that, not only do they have a minimum resolution, they also have a maximum resolution, which is like it can't show you a resolution higher than this. So the maximum resolution is how many pixels per inch is the maximum the device can show. And to be perfectly honest, for televisions and TVs, it's actually literally the same. So the minimum is 72, but it's also the maximum. So the thing about it is, if you brought an image with a higher resolution, like if I set my camera here and I set my resolution to my photographs that I filmed to be, let's say, 1,000 pixels per inch, the problem is that the device itself, which is my computer here, can't show above 72. So yes, you can do that, but you're not going to see a quality difference. And the problem here is that every time you increase the number of pixels per inch, you're going to make the file size bigger. Because at the end of the day, the thing that makes a image file large or small is the number of pixels you have. So for screen, the minimum number is 72. For print, the number you would want is 300 pixels per inch. Okay. Now, in this course, we are never printing, at least not for me. Maybe you're printing for another teacher, but for me, I'm never going to ask you to print anything. So you don't need your images to be a resolution or a DPI of 300. Okay. Why do you need a higher number of pixels for printing than you do for a screen? The answer to that question is when you print something to, if I were to take this file and send it to an actual printer, like something you would see at Kinko's, it does not print out the individual pixels. Instead, what it does is it uses little dots of color, and the situation really is that one pixel is not equivalent to one dot of color. It's not a one for one conversion. It's really more of like a 3.5 conversion to one. So you need a higher resolution for the same level of quality that you would get on a screen. Okay. So once again, this whole resolution thing has to do with whether you're printing or using a screen. In this course, we are always outputting for screen. We're either outputting for a computer screen or a television screen, in which case the maximum resolution would be 72. Okay. So at the end of the day, all of this was for me to say, for this course, I would say set your DPI to about a minimum of 72, but also probably a maximum of 72. Okay. I'm going to hit OK. Oops, did I make a new? So um, I'm going to set my file here to 800 by 600 pixels. This is my resolution or DPI, how many pixels per inch. Let's say I want to set up my composition to be played back on a TV or a computer. So I would want about a resolution of 72. This is your background color of your canvas. When you start off, I just keep it at white, but you can change that color if you want. And that's pretty much it. At least those are the capabilities of Photopea. You may have heard of something called color space. Color space is the colors that your file can work with. On Photopea, you can only work with what are called RGB files, and that's actually what we want to use for television. If you were working in Photoshop, you might be able to work with something called CMYK, but that is not what we want to use for this course. For if color space is an option, or I may say color gamut, you basically want to use what is called RGB. Okay. In particularly Photopea, there is no CMYK option. There is only RGB. So you'll notice all of these say RGB. What is RGB? Well, I don't want to go too deep into it, but essentially what an RGB is all, the way that your computer or your cell phone makes all of the colors is inside there is red light, there is green light, and there is blue light. That light projects onto your screen. That's why it's called a screen. Like, the way that think of it the way that like a film projector projects on, from the projector to the screen. So your device produces these colors, red, green, and blue, by using colored, what are called diodes. Diodes are like little electronics that produce color. And those colors mix together, kind of like, think of it as like, when you were a kid, you would mix together like yellow paint and blue paint and get green paint. This is like that, except rather than using paint and pigment, we're using light. So when red light and green light and blue light mix together, they form all of these colors. Okay. The analogy I kind of use is like, imagine you're in a theater, right? And we all know what a spotlight is, right? You can take a spotlight and project it against a curtain, right? And by default, spotlights would be white, but imagine you could put a gel on it. A gel is like, turning the color, the spotlight from white to red or blue or some other color. Now imagine you had three spotlights. Each one was, one was red, one had a blue gel, one had a green gel. You could overlap those colors and that would form, those lights and spotlights. And you would notice that all the light kind of mixes together. And that's what RGB is. Okay. This is how computers work. So when you're looking at color on your computer, that's how it works. It's a mixture of red light, green light, and blue light. This is also how your television works. Basically, anything that plugs into the wall, like a cell phone or a tablet or whatever, I'm going to guess that like 99% chance it's probably using the RGB system. Okay. Now in Photopea, you're automatically using the RGB system. You do not have an option for any other system. If you were using Photoshop or another program, there may be a way to use a different color space. You'd want to make sure it's set to RGB. Okay. So I'm going to set this up, by the way, under color. Um, this is what's called bit depth. I don't really want to get into it, but essentially what this does is it sets how many colors your image or your composition can have. Once again, this is like it's a limitation of the technology, which is that if you were to set it to 12 or 32, you could, in theory, produce more variations of color. And what I mean by that is like literally the number of colors you could make in your composition would be higher. The problem is this. It's not the number of colors you can, in theory, make. It's the number of colors your device can play back. And the problem is as far as I'm aware, the highest number of bit depth that monitors can have currently in the year 2026 is 10 bit. Okay. So if you set it higher, you can do that. But the problem is that your device, your cell phone, your laptop, whatever, it doesn't have the ability to show more colors, even though those colors technically exist. So for that reason, I just leave it at 8-bit because once again, by increasing this, you're going to increase the size of your file. And the problem is you're not even going to get any benefit out of it. Hopefully that makes a little bit of sense. So I'm going to hit create. This makes my blank composition here. And so now this is where I could paint into or, eventually, copy and paste images into. Okay. Let's talk a little bit more about working with compositions. So here, let's say I wanted to look at the composition, like the size of this particular document. I can actually do that for any image I bring into Photopea by going under image and then going where it says image size. And when I do that, you'll notice it shows me both the dimensions, usually defaultly in pixels, and it also gives me the resolution. Okay. Now I'm going to actually use this to resize my document. Let's say I want to make it smaller. It's defaultly 1000 pixels by about 666. If I come in here and I make this 500 pixels and hit tab, you'll notice that this is now 500 by 333. If I hit OK, you can see that my image got smaller. I'm going to undo this by doing Edit Undo or Command Z. When you do this, you might notice that whatever I do, the other one automatically updates. That is because of this little link thing here. This links or keeps the aspect ratio between the width to the height the same, even if you change, um, your numbers. This is actually showing the ratio. It's 1.5 roughly to 1. If you want to change that, you could undo this. And by turning this off, this would allow you to change one without affecting the other. I will tell you that if you do that, it will end up squashing or stretching your image, which I to be perfectly honest, don't recommend. So for now, I'm just gonna keep that on. I can use this to resize my image. So you can see I made my image smaller here. Let's save that. Let's open up exercise 6. So I'm going to go to image size, and you can see that this is 1200 pixels by 600. Let's say I wanted to make this smaller. So I'm just going to type in 600, and you'll notice the other one automatically updates. I'm going to hit OK. You can see that that got smaller as my image. Let's even actually go to the photo I just downloaded from Pexels. So image, image size, and you can see it gives me 40 by 480. So if I were to type in, say, 500, you can see this automatically updates for me, and it gets a little bit smaller. All right. So I want to show you, this is the last thing, and I'll let you guys try this out. I want to show you what happens when you resize a raster image. Okay. So here I have this image that's really small. Okay. It is, if you go to image size, it's like 200 by 100. Okay. And what I'm going to do is I'm going to blow this up from 200 by 100 to 1000 by 500. Okay. And I'm going to hit OK. And when I do that, it does physically make it larger, but you can see the quality looks horrible. Okay. It's very like pixelated, very distorted. So what gives? Why did that happen? The answer to this is so when you originally had 200 by 100, I'm going to pull out a calculator here. 200 pixels by 100 pixels, if we do out the math, means that my composition had about 20,000 pixels in it originally. Okay. Let's just put that. We'll say original 20,000. And then when I enlarged my image, let's make this 1000 by 500. So 1000 times 500. I've now changed the number of pixels in my image from 20,000 to 500,000. Okay. So in other words, what I really did or is we increased the number of pixels in my document. We added 480,000 pixels. Okay. I'm too lazy to do out the percentage, but that's like, we added like 10 times, more than 10 times, probably 100 times the amount of pixels than the original. So the kind of question goes like, well, where did those new pixels come from? They just magically fall out of the sky? And the answer is no. What they did is they took the original, uh, 20,000 pixels and they just multiplied them out by, here, let's do out the math. They would, in order to do what we did here, each pixel of the original had to be copied 25 times. Okay. And so the result is it doesn't look good. Okay. It is technically 1000 by 500, but it looks really horrible because it took all the data and it just copied it. And, when it comes to raster images, you don't really want to copy data because it doesn't end up looking very natural or good. Okay. I'm just going to warn you about that. All right, let's go to this other image here. So if I go to this image that's 1000 by 500, so it's a larger image. And what I'm going to do is let's make it half the normal size. I'm going to set this to 500. Okay. And when I do that, the image is smaller than it was before, and the quality actually still looks good. So what gives? Why did making it smaller, why was that okay, but not here? So once again, let's undo and do out some math. So, 1000 by 500 is half a million, 500,000, right? And then I change this to be 500 by 250. So let's do 500 times 250. And that's about 125,000. So in other words, what really happened is I got rid of, because I had 500,000 and now I only need 125. I essentially got rid of 375,000 pixels. Okay. So the thing about resizing your image smaller is it should actually maintain the quality because what's happening in this situation is you're getting rid of the excess pixels. You're keeping the ones that are relevant and you're getting rid of the ones you don't need. Okay. So what did we learn here? What we really learned is it's better to make a bigger image smaller in terms of quality than to take a small image and blow it up bigger. Okay. So if you were in something like pixels, keep in mind that you might want to choose a larger size because you can always make it smaller without losing quality. But the reverse is not true. If I took this smaller image here and I tried to blow it up larger, it will distort it. The level of distortion depends on how much you're, enlarging it. But, it's generally not a good practice, is what I'm trying to say here. Okay. So just keep that in mind when it comes to dealing with resizing images. Okay. So that was six, seven, or sorry, it was, yeah, five, six, and seven, please. Okay.